hello and welcome back to Isifundi Training and Bite-Sized Corrosion. I'm Vanessa Seeley-Fisher and it's a delight to host today's discussions. Now today we're going to be talking about something a little more modern, can I say, than the epoxy and polyurethane technologies which we've already addressed. Whilst those technologies originated in the 1930s, so we're coming up for nearly a century, today we're going to be shifting our conversation to talk about a product line that was really developed in the late 1980s and early 1990s. And so whether you're a professional working with high-tech coatings on a daily basis, or if this is a topic that you know little about, we know that you're going to find valuable insights during our discussion today on polyureas. And I am really delighted to welcome Anthony Wright of Chemthane to the microphone to help us explore polyureas in a little more detail. So welcome, Anthony.
Thank you, Vanessa.
Anthony, I hope that as a result of our conversation today, our viewers are going to get a better understanding about polyureas. And I am aware that many of us confuse polyurethanes and polyureas. Can you help us to demystify this a little bit?
So there's a vast difference between polyurethanes and polyureas. They do stem from the same chemistry, but they split off at the point where polyurethanes essentially are a reaction of polyols and isocyanates, and polyureas are a reaction of polyamines and isocyanates. And this gives the coating product two very, very different properties, specifications, if you want to call it that. So a very big difference in the product.
Okay, so you say that there are these differences. What would be the difference between, so if you've got this amine group versus the polyol group, what are we looking at in terms of the differences?
So with polyurethanes, utilizing polyols, you end up with a reaction of two products that give you typically softer products with higher elongation levels. So typically used in applications where perhaps abrasion resistance is more of a requirement as opposed to corrosion resistance. Polyureas, because they use polyamines in their reactions, react very, very fast and have a very high crusting density. So they tend to be in the harder range of coatings, where polyurethanes typically would range from 60 Shoei up to around about 85, 90 Shoei, maybe 95 Shoei. Polyurea start coming into their own at about 90, 95 Shoei up into the D range. So you're getting very hard products as well. Along with this high crusting density that polyureas offer, they offer you a better corrosion resistant product. Perhaps not as good on abrasion compared to polyurethanes, but certainly better from corrosion resistance and, of course, chemical resistance.
Okay, right, that makes sense. So typical applications for a polyurea?
So polyureas will be utilized in protection of steel and concrete. You can obviously use them in other applications. They bond to most substrates with the application of a suitable primer. But generally speaking, they are used mostly in concrete protection and steel protection, or corrosion resistance, chemical resistance, crack bridging. And what makes polyurea so versatile is obviously the speed of application compared to, say, other traditional coatings, which have much longer cure times. So polyureas can be applied at a very, very fast rate, and turnaround times can be reduced greatly because of this application speed.
I can see that the manufacturing sector eyes will light up because there's less downtime there, and I can understand that would be quite valuable. Are there other attributes? So if you've got these two components, your polyamine and your isocyanate, you didn't mention a solvent. Are these solvent-free coatings?
So polyureas are solvent-free. They're designed in such a way that they can be applied at fairly high draw form thicknesses because of their solvent-free attributes and because they can react really fast. So polyureas can be applied on vertical surfaces and horizontal surfaces as well as overhead surfaces without dripping or sagging because of the very fast application rates. No solvent involved at all in the process, and including the cleaning of the spray equipment. The spray equipment itself is self-cleaning, and at the gun, when polyureas are mixed, they're mixed through a method of impingement at very high pressure, running at high pressures in the region of about 200 bar pressure at high temperature, 70 to 80 degrees C, coming into a spray gun, which comes into the spray gun and it's atomized in the spray gun, if you want to call it that, which we call impingement, and then gets pushed through into the nozzle, which you have different sizes like you have with every other coating, and then applied. This allows the applicator to trigger the gun on and off to ensure that it gets even thickness, even coating thicknesses throughout his application, and it doesn't involve any solvents. So it's from an environmental perspective, it's a good thing to process as well.
Now, you've mentioned it's at high temperature and that it's a very quick reaction. I know when we were talking about some of the other products, epoxies primarily, but also polyurethanes, is that there's a difference between their, can I call it, touch temperature and cure. Is that the same experience with the polyurethane, or do they also cure quite quickly?
Polyurethanes do cure quite quickly. And, when we talk about curing quickly with polyureas, you can have anything from 3 to 5 seconds as a cure time on the harder products, whereas polyurethanes would cure from about 30 seconds to a minute. What influences drying times in the polyurethanes, or polyureas for that matter, is substrate temperatures. And of course, that's then, that needs to be looked at when applications are done. But polyureas, and there's been a lot of hype over the years on polyureas that it can be sprayed on any substrate and it'll cure on any substrate. That's true, it will, because of the very fast reactivity. But the question is, will it adhere to the substrate?
Fair comment.
Obviously. So you still have to follow the same procedures in surface preparation. You have to have a specification on surface preparation for polyureas to work properly.
And I would imagine that they're also going to largely need some sort of primer, because if they're curing so quickly, they're not going to wet out on the surface.
Yes, so any surface preparation which has any level of blast profile, in order to have that wet out properly, we would always recommend a primer, whether it be steel or concrete. They sometimes have different primers. Sometimes they use epoxy systems on concretes, and sometimes they use polyurethane primers on steel. It depends on the substrate. But we would always recommend a primer, because you need good wetting out. It's no good to have, sometimes in-house applications can get away without primers, but then it's literally a blast, and the coating takes place as soon as the dust and debris have been removed. But that's really under controlled in-house conditions.
Right. In your general maintenance type application or on-site application, you would need a primer. Yeah, that's worth knowing. So they could be regarded by some as the kind of perfect coating, useful everywhere, but I'm sure, like everything, they have a real side to them and there are some drawbacks. What would you say are the most significant things you need to think about?
With polyurea coatings is, firstly, the equipment required to apply the product. These are typically high-pressure airless spray equipment. People like Graco manufacture a range of machines called reactors, which are typically very expensive. So your entry to level is high. You're talking in excess of R500,000 for the spray equipment. You need to have a fairly large compressor or electrical supply. Some of these machines are hydraulically driven, some of them are air driven, but you need a lot of backup equipment as well to go with the machine. So there's a lot to consider. Apart from that, like any coating or any product, they have restrictions. Polyureas have good chemical resistance, but they don't have the chemical resistance, say for argument's sake, of vinyl esters or epoxies. Polyureas have good abrasion resistance, but they don't have the best abrasion resistance, say, compared to polyurethanes or to natural rubber. So one needs to be aware of the drawbacks of, I would suppose, any product, but there are drawbacks and there are advantages. So polyureas do have, for argument's sake, a good ability to bridge cracks, depending on the hardness selected. So for concrete, where concrete might move, polyureas have good wear properties. So they have good for traffic, whether it be vehicle traffic or industrial traffic. It does have those properties. So there are pros and there are cons, and it's really important to understand where these products fit into the spectrum of coating products.
I think you've raised a very valid point there, because I think that's something that's valid for any coating, is that
absolutely
every coating has its place, but not every coating has its place in every place. And we need to make sure that at the specification level that we're choosing the right product for the right circumstances.
Absolutely.
Anthony, what about cost? As a South African, I'm assuming that these are largely imported, if not as the product, certainly as the raw materials. That has a forex aspect to it.
Yes, there is. So none of these raw materials that go into making polyureas are locally manufactured. There are a lot of raw materials that are brought in by distributors or directly by the suppliers, and they are then manufactured or blended up, if you want to call it that. There are a lot of products coming in from overseas. The USA is a very big supplier of polyurea. It's a very big market for polyurea. And of course, out of Europe. Some of your older polyurea manufacturers find themselves in Europe. So these systems are either fully imported as polyurea systems or as raw material to be blended into polyurea systems in South Africa. So that adds to cost. And of course, that adds, we're dealing with forex. And polyureas are certainly not the cheapest coating system in the coating spectrum, but it depends on the application. Because of the speed of application of polyureas, sometimes the cost can be negated because of the lower or the reduced downtime that one could experience with polyurea systems.
And I can imagine that from an applicator's point of view, you probably want the assurance of quite an extensive amount of work, given the capital cost as well that you're dealing with.
Correct, yeah. So obviously what's required is if you're going to invest into the equipment, you will then have to have a certain level of work coming through annually to make sure that you can recoup the cost on the equipment. So it's very important to market the product correctly and to the correct customer base. The other advantage, which I failed to mention earlier on, which is quite useful, is particularly for site work when weather is an issue. Because polyureas can be applied in a rapid rate and they dry rapidly, you can overcome the weather issues, whereas a slower curing product like an epoxy may be affected by weather in terms of its curing rate or curing times. Polyureas don't suffer from that same problem.
Okay, I can see that being a definite advantage. Just in terms of use in South Africa, are we finding that there's a fairly large segment of the coatings market here in South Africa that is occupied by polyureas, or would you say that this is still a growth area?
I would say it's still a growth area. There's a lot of interest in polyurea. I'm starting to see, particularly up in Africa, there's a lot of specifications calling for polyurea coatings. So these are mines up in Africa where there's maybe a European influence or Asian influence, something like that, where they are calling for polyurea coatings as opposed to rubber linings or polyurethane linings for that matter. So there is an increase in the interest. Cost of polyureas tends to scare people away a little. And so what's actually happened in the market is a lot of people offer what they would call hybrid polyureas, which then is I would call it a blend between a polyurethane and a polyurea. So they're adding some of the polyol components from polyurethanes into polyureas. Yes, you do get technically a lower cost polyurea, but it's a hybrid and it won't perform the same way. So when we talk about polyureas, we always talk about hybrid polyureas or pure polyureas. And a lot of the market sometimes has a misunderstanding between those two. They don't perform the same way.
So as soon as you are looking at a hybrid product, you are probably looking at reduced functionality or reduced capability within your...
Correct. So reduced chemical resistance or reduced wear resistance, certainly reduced cost. And there are areas for applications for hybrid polyureas. No problem. There's no doubt about that. For argument's sake, caulking, expansion joints where you want to maybe work through a cartridge, hybrid polyureas can do the job perfectly for you there because they do have a longer reaction time. Hybrid polyureas can go up to 20 seconds for argument's sake, or 25 seconds. So it gives the people a little bit more time to work with, and they can be processed at slightly lower temperatures. So there is a place for them, but there should be always an awareness that there is a difference between the two families of polyureas.
Yes, as soon as you see the word hybrid or discount or the caution, the flags should be raised.
Yeah.
I'd like to take a diversion back to the chemistry. You spoke about this use of a polyamine with an isocyanate, and my interest is really, is that an aromatic, sort of tightly bound structure, or is there a place for an aliphatic or a linear structure?
So the majority of polyurea systems out there today are aromatic based. So they're based on aromatic chemistry. Your isocyanate, obviously, basically is aromatic and using aromatic amine. And that's really your entry, your cost base there is as low as it can go because it is cheaper to produce these products and they're more widely available. However, aliphatic polyureas have made their entrance onto the market a couple of years ago, and that's obviously used in very specific applications where people need color and UV stability. Polyureas and polyurethanes don't break down in the same way as, say, rubber does or, say, epoxies do. They tend to discolor, though. So, for argument's sake, in an aquarium application or a swimming pool or a wave pool application, the specification will have to call for an aliphatic polyurea system as a top coat. Certainly as a top coat. It doesn't have to be the complete all the way through, but then there's a big price difference because aliphatic chemistry is far more expensive than aromatic chemistry.
Now, you mentioned pools. I know that's not a corrosion application, but is that a big application for polyureas?
It is. We've seen a lot of it, particularly in the Middle East, with the building of these big resorts in the Middle East, in Dubai and Doha, Qatar, those types of places. A lot of the applications for polyureas have come through their swimming pools, these big wave pools, these massive wave pools. The guys are doing a lot of those types of coatings. So that's a slight move away from the traditional corrosion or chemical or the industrial applications, but that is a very big application area. and they've been very successful there.
And I imagine there this UV stability
Correct.
component becomes extremely important.
Yes, their UV stability and, of course, color stability, because they're using colors like light blue. And if you use an aromatic system, your light blue will become green within 24 hours or 48 hours. So you'd have a very unhappy customer. So yes, that's where the aliphatic chemistry comes into its own. But you can be sure of aliphatic chemistry would be roughly double the price of aromatic chemistry. If I look at pricing around the world, €5 versus €10 per kilogram is the difference. But again, it has its advantages.
Yes. Where would you say the most polyureas are used here in South Africa? Would you say that's in the mining sector?
A lot of it's used in the mining, in the industrial sector, I would call it. So a lot of it's used in acid resistance, protecting concrete against acid resistance, bund areas, bund walls, tank linings. Going into the mining industry, steel protection. One of the big applications in mining industry, which is coming to the front now, is the application of polyureas as a replacement to rubber lining, particularly in secondary milling applications where gold, for argument's sake, can find its way behind the rubber lining and you end up with losses. Polyureas are seamless. They offer a level of abrasion resistance, but the big advantage is downtime is reduced from, let's call it 7 to 10 days down to 2 to 3 days. And that has a big saving for the end user, the client.
I hadn't thought of that as being such a practical application, but I do see the merit of it. And if you're getting some of that wear resistance in, and use of rubber lining is becoming less frequent, I think, and sadly with that means that we're losing the skills to actually apply the lining correctly. It's good that there is a replacement in the polyureas.
That is becoming a problem. And of course, one of the big problems with rubber lining, of course, is disposing of rubber lining once it's had its life cycle. So that's all something to think about. You see this often with conveyor belting, how difficult it is, in the market. There has to be a cradle to grave scenario. So polyureas in this regard would be a better option in cases like this. One of our application areas is applying polyurea to concrete, and we all know concrete is at best at times an unknown. And it's particularly concrete that hasn't been treated or protected before in acid bund areas. So polyureas work very well there. And because these plants, for argument's sake, a pickling plant, which has an acid environment all year round, when they come onto shutdown, you're literally limited to 2 weeks to get in, repair the concrete work and coat it. And that's where polyureas really find themselves. That's where they really are leaps and bounds ahead of other products, because you can get in, get out, do the repairs and coat the product and get the concrete coated.
So perhaps a difficult question to answer. I can see that the polyurea is going to be easy to apply. What is the risk of contamination already in the concrete pushing back, if I can say that, onto the product? Is that a challenge with polyureas?
Yes, it's a challenge with polyureas. It's a challenge with any product. This is where it's so important to understand what is available on the market. So there are underlay products, if you want to call them that, cementitious epoxy systems, which can be applied first to allow to act as water vapor barriers before. Otherwise, you will end up with the typical blistering. Because polyureas have a high cross-link density, they have a low water vapor permeability, which is good from the outside, but bad from the underside. So you could end up with blistering if the concrete's not treated properly. We tend to use water-tolerant epoxy systems as primers, but in all fairness, they also have limitations. So you've got to be quite careful, and you've got to understand your concrete substrate fairly well before you go ahead and coat it.
And that, I think, is the big challenge, and maybe one day we'll do a whole discussion on concrete, but it is that you're dealing, as you said, with this unknown, and every concrete structure is its own unique set of concrete parameters in so many ways.
Even brand new concrete can be challenging. So it's a special type of applicator that needs to address this, and you need a combination of products. One product will not fix all in those cases.
But if I heard you correctly earlier in the conversation, you said that the advantage with concrete is also that if the concrete starts cracking, there's a bit of flexibility within the polyurea to be able to accommodate that.
Yes, polyureas have elongations up to 300 or 400%, typical polyurea, depending again on its hardness. And that allows some movement ability on the concrete as opposed to products with very low elongations. So they do have the ability to move, which will crack bridge.
That's also, I can see a huge benefit, especially in the mining sector where they're dealing with lots of ancient and sometimes unknown
Correct.
historical
And obviously
challenges.
a lot of seismic movements in the mining industry, which doesn't help concrete at all. And that's where polyureas can work well.
Kind of hold it all together.
Correct.
Oh, that's excellent. That's so interesting. And it's interesting to me that is really a niche market in South Africa that has found a good usage of this product, where it may not necessarily be widely used on other industrial uses of steel and so on.
That's right. Yeah. So it's from a client perspective, it would be very beneficial to them to have a understanding of it, so that they can plug these products into specific applications in their industry or in their plants, so that there is certain areas which can be completed with polyureas when other products from other areas. So it will depend. Yeah.
And then that goes back to something you said right at the beginning. It's really important that we have excellent specifications, well written, so that you are always choosing the right product for the right application.
That's correct, yeah. So guys who are writing up specifications need to have a good understanding of what they're applying and the combination of products that are being applied onto a certain substrate. You know, steel being one thing, but concrete certainly being a different kettle of fish altogether.
Well, Anthony, this has been absolutely fascinating. Thank you. You've mentioned, obviously, you're very knowledgeable in the mining sector. You refer to polyols being used with swimming pools. What is the most interesting application of polyureas that you've encountered, or one that perhaps you didn't think about, that it really has been the right thing?
Well, not us particularly, but in South Africa, there are some casinos, for argument's sake, which have roofs made from polystyrene. And the polystyrene is overcoated with polyurea. This is a very, very popular thing in the US. They do this often, where they need very specific shapes to, for argument's sake, in a theme park, where they need a specific shape which is cut from polystyrene and then coated with a hard polyurea. Again, you need to be careful, because there can be some drawbacks. If you go to Secunda, if you go to the casino, the Graceland Casino in Secunda, notice it has a blue roof. That's coated with that's polystyrene with polyurea over the top. And that for me was quite an interesting learning curve as well, because the Americans didn't understand how our UV works here. African UV is a little bit different, and they had to eventually overcoat it with an aliphatic coating, because they did get discoloration in the beginning. So that was one of the more interesting applications I've been involved in over the years. I wasn't directly involved in application as such, but more on a consultancy basis to try and help them get the project finished. So, yeah.
Troubleshoot it. That is so interesting, because, you know, when you're out in the casinos, for example, you know, what you see is very often a figment of our imagination to some extent, aided along with some polystyrene and some polyurea.
That's right, yes.
More polymer chemistry than we thought was surrounding us.
That's right, yes.
Well, thank you so much, Anthony. Thank you for helping us to understand polyureas a little bit more.
Pleasure.
You've certainly opened my eyes to some different applications. And I have to confess the realization that I know we've barely scratched the surface of the product, as it were.
No, that's true. It's a vast market, vast product range. It's a relatively new chemistry, you know, only developed late in the 80s in the UK, but it has found a place in the industry. And I think there's still quite a few developments that have to be considered and done with these products. They're becoming more widely available throughout the world. The raw materials have become more widely available as well, which is interesting for us. More accessible, I would say. And that allows us to formulate different products with different properties more regularly.
Well, it's been fascinating. Thank you. And I do hope that our audience feels that we've also broadened your knowledge with this topic and helped you to at least identify some of what you may not know. So I'm going to encourage everyone to follow us on Instagram, LinkedIn, YouTube, all the socials, and then you won't miss out on what we're up to and the interesting discussions that we have.